In the last class, we have discussed the reactions of alkyl benzenes, and we have, discussed that alkyl benzene undergo nucleophilic substitution at 2, 4, and 6 positions, right?
Yes.
Okay, now the next reaction is hydrogenation of alkyl benzene. So basically, this is an addition reaction as alkene undergo. In this reaction, benzene heated with hydrogen gas in the presence of catalyst, and the catalyst we use over here is platinum or nickel. Okay, just do the correction, right? Alkyl benzene, and benzene will do the same as well. Cyclohexane is formed no 1 minute. Just leave this statement. Have a look over here. For example, I have a methyl benzene. In this benzene ring, which is bonded to a methyl, how many carbons have a hydrogen? Except the one where there is a CH3. And how many carbons are involved in the pi bonding? Yes, in this benzene ring, how many are involved in the pi bond system? All of them, because there is a circle. We making the sphere. So when we react it with hydrogen, it reacts with 3 moles of hydrogen, and platinum or nickel is used, and here we have to heat it. So when we heat it, we have to heat it more than the we heat alkene, because it is the pi system is more stable. So the reaction would occur at relatively very higher temperature as compared to an alkene. And then what will happen? The pi system broken down, and all of the carbon got one hydrogen each, making it a saturated cyclocompound, and it is called as methyl cyclohexane. Okay, on Friday we are going to have a class. Yeah. There are 2 possible timings. Either we can do the class at 6 to 7 or 4 to 5. Yes, when can we do the class? Both timings are available.
Sir, I'm fine with both.
Sorry, Maham, can you repeat?
I'm fine with both.
Okay, you are fine with them. Yes, Yusuf and Kubra. So when we react a benzene with hydrogen, so the same reaction will occur, and now we will get a just a cyclobenzene or cyclohexane. It's a methyl benzene which is converted into methyl cyclohexane. And it's a benzene which is converted into cyclohexane. Yes, are two equations clear to all of you? Yes, Kubra, Maham, and Yusuf.
Yes, sir.
Okay, Kubra and Yusuf, just tell me whether which time is feasible for you guys for an extra class on Friday, 4 to 5 or 6 to 7. Six to seven is fine with you, Yusuf? Yes, what about you, Kubra? 6 to 7 is fine with you as well? Okay. Then we will do a class at 6 to 7 on Friday. Okay. Now, hydration of alkyl benzene. Okay, we didn't did the oxidation of side chain, right? Or you can say oxidation of alkyl benzenes. So, alkanes are not oxidized normally in the same way benzene also didn't oxidized. But in alkyl benzene, the alkyl side chain can be oxidized if carbon atom of alkyl side chain that is bonded to benzene ring has at least one hydrogen atom bonded to it. Is this point is understandable to all of you?
Yes, sir.
So it means, see, this is a benzene ring. And here a carbon atom. And that carbon have three more bonds. Out of three more bonds, if it is bonded to at least one bond with the hydrogen and either rest of the bonds are alkyl, then this carbon, this carbon can be oxidized as bonded to at least one hydrogen atom. Is this clear to all of you?
Yes.
Okay, just give me a minute, please. Okay, extremely sorry. So where were we? Yeah. So for example, this is we have another benzene. And if you see the rest of the three bonds of the carbon which is directly bonded to benzene is with the alkyl chains only, with the carbon chains. So now this can't be oxidized. As no hydrogen is bonded. Is this point is clear to all of you?
Yes.
Okay. On oxidation, benzoic acid is formed alkyl benzene is refluxed with alkaline. See, in the rest of the oxidations, we use acidified conditions, but here we will use alkaline conditions. Alkaline potassium manganate 7, and then acidify with dilute sulfuric acid. Okay. So if it is not Yes, am I audible now? Sorry, it was disconnected. Yes, am I audible now?
Yes, sir, you are.
Okay. So we use alkaline KMnO4, alkaline potassium manganate 7, and then acidify it with dilute sulfuric acid. And why we acidified it later? Because if it is not acidified, what we are getting a benzoic acid as a product, right? If it is not acidified,
Yeah.
then a salt of benzoic acid is formed, because benzoic acid is itself an acid and the medium is an alkaline, so acid and base always react, right? So to get the benzoic acid only, not its salt, we will, acidify it later. So I'm just giving you a minute. We have a methyl benzene. And here we are going to show you atomic oxygen, which means we have used oxidizing agent, and on the arrow we will put that oxidizing agent and the condition. So the condition are alkaline. For alkaline, we will write OH negative and then KMnO4. Then we heat and then we add dilute sulfuric acid. So that the carbon bonded to benzene bonded to benzene converted into carboxylic acid, and this is called benzoic acid. Along with it, water is formed. So here it is benzoic acid. Okay, so only this product will form if there is a carbon which is bonded to a benzene ring have at least one hydrogen. No matter how many long chains are there, all of those long chain will be eliminated, will be broken down, and this will convert into this carboxylic acid. Is this clear? Okay.
Yes.
In the form of chemical formula, I will write this equation like this: C6H3. Okay, to balance the equation, I have to put a 3 over here. And we are going to use the same conditions. And here it will be C6 H5 CO2H plus H2O. Okay. Now, after this, I am going to write two half incomplete equations. Now you have to tell me in which equation the product will form, then make the product, and in which equation the product will not form. Okay. Now complete these two equations and then WhatsApp me quickly. Okay. Yes, Maham, Yusuf, and Kubra are both going to convert into the benzoic acid, or only one, and if one, then which one? Yes, Maham.
Yes, sir.
Can you tell me, are both are going to convert into benzoic acid or only one? Yes, Yusuf or Kubra?
Sir, I think only one.
Which one? Yes, which one then?
The second one.
If you look at the second one, this is the carbon which is directly bonded to a benzene, right? Right?
Yeah.
This is carbon, and if you see, it is bonded to carbon, carbon, and carbon. Does it bonded to any hydrogen?
No.
So it means in second one, there will be no reaction. It will not turn into benzoic acid.
सर
Yes.
सर पता कैसे चलेगा कि हाइड्रोजन है या नहीं है?
Look at the skeletal structure. If you look over here, from here, three bonds are arises. So here it means this is a carbon which is of benzene. This is a carbon and this is a carbon. So but bond is not shown, which means that there must be a hydrogen over here.
Okay, sir. Okay.
So if there is a this carbon have at least one hydrogen, then it means this carbon can be oxidized. And now here we are going to get a benzoic acid. Yes, is this clear?
Yeah.
Yes, Yusuf. Yes, Hassan. Yes, Kubra. That are not the part of our syllabus. Yes, obviously there will be two other products, because if you see here, there this and this carbons are broken down, these alkyls. So they must be converting into some other products. But we have to make the benzene and the carbon which is bonded to benzene into benzoic acid, and we don't have to, look into the other products which are what products are forming. Okay, so here we are done with all the compounds which are related to benzene. Okay, there is one more thing that I have to discuss over here. If benzene have nothing bonded to it, then the electrophilic substitution can occur on any of the carbon, right? Yes. if nothing substituted on benzene, then the electrophilic substitution on benzene can be occur on any one of the carbon, and that carbon is considered as one, right? Yes, is this clear to all of you, this point? Okay.
Jeez.
Now, if for example phenol, the OH group is bonded, so we have seen that the next substitution is taking place at 2, 4, and 6. If phenylamine is there and H2 is bonded to a benzene, then the next substitution is taking place at 2, 4, and 6. In the same way, when methyl and the halogens are bonded to a benzene, then the next substitution are taking place at 2, 4, and 6, right? So you have to know those compounds which can, when they are bonded to a benzene, then the electrophilic substitution occur at 2, 4, and 6. So if there is a R group, which means alkyl chain, if there is a OH group, if there is a NH2 group, if there is a OR group, if there is a halogen, if there is a NH COR group, if any one of these groups are attached to benzene, so these all groups are electron donating. So if they donate the electron, so the electron charge density will be increased on these three positions, and the next substitution occur at these three positions. But if benzene have NO2 group bonded to it, or NH3 positive group, or CN, or CHO, or COOH, or COR, or COR group, or CO2R group, then all of these groups are electron withdrawing. So when they withdraws the electron charge density decreases on the benzene ring, and specifically at these three positions only, which are 2, 4, and 6. So as a result, the position 3 and position 5 have a relatively higher negative charge density. So in case when these groups are bonded to benzene ring, and then if we do the electrophilic substitution, so it will occur at 3 and 5 only. Is this clear? Yes, Kubra, Maham, and Yusuf.
Jeez.
Okay. So, I think it's fine till for today, and the next class I will extend a little on Friday, and then let's see, we'll start with all the past paper questions from the benzene, and then if we will have a time, we will move to the carboxylic acid derivatives on Friday. Okay.
Okay, sir.
Okay, then take care, everyone.
Okay. Allah Hafiz.
Allah Hafiz.
No.
Allah Hafiz, everyone.